the church and mission in Bagamoyo, and it's still there. And that's a picture of it on.
Is about the handshake problem and real-life maths through identifying number patterns. Today is all about number patterns. It's about handshakes, and we've converted it to bows. Normally it's always handshakes. So how many handshakes there are for everybody in the room to have shaken hands with everybody else in the room. That's the essence of it. But to be able to work it out, you need to be systematic, you need to look for patterns, you need to solve a problem, use all those skills that are useful in life and in becoming a mathematician that enjoys maths. It's really useful developing these skills in the classroom so that you can enjoy and become good at maths.
This is an activity that you can do with any age, certainly younger children than secondary, and they'll enjoy doing it. Depends how you manage it, but we're going to talk about that this afternoon. Suppose everyone in a group of 20 must shake hands or bow to everyone else and say hello, and it's got to be one-to-one. It's a one-to-one greeting. How many handshakes will there be altogether? Now, it could be more people. Let's talk about different numbers of people, but in this graphic you've just got problems posed for 20 people. Handshakes are not a good thing while we've got this pandemic. So we thought the Japanese style bow was a good idea. And I discovered that depending on the angle that you bow, it's a one-to-one greeting. And Japanese people usually know the age of others that they are going to meet, because the older the person that they are greeting, the lower they should bow. Well, generally it's the more senior, but since age is often recognized as being a criterion for seniority, older people tend to get a low bow to them when somebody else is greeting them. So I would get everybody bowing really low to me.
I was wondering on this one, Tony, and I didn't ask it before. I wonder if it's relative. So how low would, say, two people that were 80, how low do they have to bow to each other? They have to go the full 45 degrees?
Oh, I'll have to ask my Japanese friends about that. But it is very hard for Westerners to get it right, actually. So it's a different culture.
So we were talking about people maths last week, weren't we? What a great way to do people maths, to get the young learners to actually bow according to how many degrees the angle is, and get a really good feel for it. And also with your legs as well, you can do it with your legs or your arms and represent it with people maths that way.
I don't think it's got to be precisely 15. I think 17 or 18 would do.
So we're rounding again.
For the purpose of this problem, though, it's simply a one-to-one greeting. Or, you know, in the theatre, one actor on the stage bows to many people. But in this particular context, it's a one-to-one greeting. Now, I love this picture. It's bare brick, breeze block type brick, and there's no windows. There's a class there of boys and girls, Muslims and Christians. It's in a place called Bagamoyo, which is not far from... It was just fun that afternoon. I mostly work with teachers, training teachers, but this time I was asking them a question. I thought I would tell you a little bit about Bagamoyo because it's a very interesting place. In the 1870s, a wealthy Arab who was Muslim gave some land to the Catholic Holy Ghost Fathers to build their church and mission in Bagamoyo, and it's still there. And that's a picture of it on the right. And you see all the history there on the paintings behind the high altar. You can see on the left-hand side the people, the slaves carrying heavy loads, including ivory, and they were captured and brought to the coast, and then from Bagamoyo they crossed to Zanzibar and were sold in the slave market. But these holy fathers rescued the ones who were left to die by the wayside because they appeared to be, just at the end of their lives. And they did help some of them to return home, but many of them just didn't know the way where they come from and couldn't go back home. So they were taught how to grow crops and how to build houses, and of course taught about Christianity. And there you have the high altar for that church, which is a very big church. But you can hear the church bells and you can hear the call to prayer in the mosque. And it's not a very big town, it's very small. It's half and half Muslim and Christian, and everybody lives very happily together.
So the connection between that and the handshakes.
Well, you see, you shouldn't. I once made the terrible mistake of offering to shake the hands of somebody when I met him at the airport, from Nigeria, actually, and he was a Muslim. And they don't shake hands with women, right? Muslim men will not shake hands with a woman. And so the bow would have been much more appropriate there.
So culturally, so this is highly relevant to this activity, because you've got to be aware of the culture of the people doing the activity. Looking at the example that we started off with, if you had 20 people in a room and everyone had to shake hands with everyone, how many total handshakes would there be? 20 people in a room and everyone has to shake hands with everyone. Sounds complicated. Tony's going to break it down for us so that we can find a way.
Well, there are different ways to look at this, and we'll talk about it again next week. And there is a way that some people get there very quickly, get to the answer very quickly. I've done this quite often, where the children are actually lining up outside the classroom before the lesson. And you say to them, well, when we go in, then everybody has got to shake everybody else's hands. How many handshakes will that be? So supposing there are 35 children, how many handshakes would that be? And if they just go in and everybody starts shaking hands with everybody else, there'll be a lot of giggling and merriment, but they'll lose count of who they've shaken hands with and who they haven't. And it's very hard to be systematic in that situation. So generally, they have to sort of think it out and make a plan. Now, in problem solving, a very good way to solve problems is to start with simple cases. So if it's hard for you to work out how many handshakes with 20 people, then let's just start simple. How many handshakes if there are just 2 people? Well, that's easy. If there's
that's super easy.
Right, so you see that on the board. The number of people 2, the number of handshakes 1. So if there are 3 people, so if there are 2 people in the room and another person comes in, and the 2 people in the room have already shaken hands, how many handshakes have there to be for all 3 of them? And the answer is there'll have to be 3 handshakes. It's not hard to work that one out.
Yeah, that one, I can do that.
Now then, the next question is, remember, this is a general technique for solving problems, not just for this particular problem. It's rather a good idea often to start with simple cases for small numbers. So if you get to 4 people, then you can ask the question again, 4 people. And that is exactly what this group of 4 girls is trying to find out. They're at the front of the classroom. They're all working out, by actually doing it, how many handshakes there will be if 4 people have to shake hands with everybody else in that group of 4. And the other students in the classroom are watching them and thinking about it. Okay. And there you see on the board what is being recorded. And the question is, how many handshakes is it going to be if there are 4 people? And the girls, of course, they found that out. What do you think? Well, we won't give the game away. If you have thought out the answer,
you can put your thoughts in the comments, and it doesn't matter if you don't get it right. You know what the most powerful thing is? It's not about getting the answer right. It's about doing the thinking. And if you have a stab at it, you will learn so much more than if you don't have a stab at it. If you just wait for the answer to be revealed or the explanation to come, you will learn a whole lot less than if you have a stab. You might get it completely wrong. You might have got the wrong end of the stick. But if you have a stab at it, your understanding and the learning that you have will be so much more powerful, so much deeper. And you'll be able to also have a lot of insights to help others learn it.
Well, I did say that these students worked in groups. And I think rather than it being a pencil and paper exercise, it's best really, and it's more enjoyable for the learners if they're actually working in groups and actually doing a practical activity. So here, sometimes you said just now, Caroline, that people can get confused about exactly what the problem is and be in a bit of a muddle and not quite sure what question they're really trying to answer. So by having some students at the front there demonstrating it, they're making it quite clear. Everybody's thinking now in the classroom, they're trying to make it clear what is involved with everybody shaking hands with everybody else. And they come up with an answer. And then what we did was, and they sat down, and here you see there's a group of 5 boys, and you can see they're shaking hands, and the whole class now is working in groups of 5. Having got the answer for 4 people, they're now working on what is the answer going to be for 5.
I'd like to point out here as well, Tony, look at those faces. Look at where the eyes are going. Look at the enthusiasm level, the energy level in those young learners, and think about how it can often be in a maths class not like that, basically. And so I just really wanted to point that out. That picture really shows you the leveling of engagement you will get doing this activity.
And this was a classroom in a building, which if you were watching at the beginning, you may have seen, but I did mention that there was no glass in the windows. There were just bare brick walls, and very poor in terms of, not poor in terms of the education, but poor in terms of the resources. But you don't need a lot of money to teach maths. You do need a lot of good ideas. And what we specialize in at Aimsec is helping teachers to make maths enjoyable, helping them to make it practical, and sharing with them ideas for when you do need some actual equipment to make it from junk, so that it's not going to cost the school anything. Well, if they haven't got any money, they can't buy equipment. So we help them to make any equipment they need from junk. In this case, they just need to think, really.
Yeah, you give instructions, not help you make it literally, but it's like everything, all the activities are thought out, and all the activities are prepared in a way that you can make the resources from junk. There's on the bottom of the screen, can see it going past facebook.com/Aimsec SA. That's the Facebook page of the Aimsec activities. Basically on there at the moment it's all daily maths starters. So every single day you'll have something different coming up. The weekends have games, the weekdays there might be the same theme all week with a different little starter each day. It might be based on numbers, it might be based on shape, it might be based on probabilities, all kinds of different ideas. And in this particular instance, well, everything is backed up. Everything that you see on the Aimsec page is based on activities on the Aiming High website. Now, Tony founded this organization, Aimsec, in South Africa originally to help provide professional development for South African teachers. It's expanded to the whole of Africa, and well, the whole of it's available to the whole of Africa. And now we've just initiated the global network empowering teachers globally, as the name says. Everything we do is based on the activities on the Aiming High website.
What Caroline has just been saying about the Facebook page, the Aimsec Facebook page, is as a daily starter. If you go to facebook.com/AimsecSA, and you will see there a starter.
And it has a link to the follow-up activity, which is comprehensive. It's originally designed for teachers, but it's understandable by anybody. It's got diagnostic questions to help you understand where the learner might have some confusion or misunderstandings. It's got key questions to ask to help the learner work out the answer. And these are really, really rich activities, and all designed so that they can be made using junk, using recycled materials.
So we'd call it a starter because there's a little problem, a little question, a little activity or game in that post on Facebook. But there's also a link that takes you to the Aiming High website, and there Caroline's been talking about is what we call a learning pack. So for Handshakes today, there is a learning pack, and it consists of worksheets for children, it consists of notes for teachers, and it consists of what we call an inclusion and home learning guide. And that's to help families at home, if the children are out of school and not getting work to do given them by their maths teachers, they can do these problems at home. And we've designed them for a mixed group, well, a group of mixed age, so that there's a starter that everybody can do together, whether you're 18 or 8 or even younger. And then there's activities, separate activities for different age groups. So each one of these packs covers the full age range of school mathematics and even preschool. And also it just takes you in and helps you to teach better if you're a teacher, or to do some maths with your children at home. Of course, it also helps the many households, families who do homeschooling.
Yes,
okay.
whether it's home education, that you always do home education, or whether it's home education because you're
understand quite a lot about mathematics, you might sit down and work this out in 2 minutes. Honestly, you might. Okay, and there are different ways of, different methods of solving this problem. With a group of younger students, they will naturally want to start counting. They will naturally want to think, you know, I've got to shake hands with everybody, and everybody else has got to shake hands with me, and everybody's got to shake hands with everybody else, and they want to start counting. Now, it's quite difficult to be systematic if you're going to do it that way. It's quite difficult to keep track of who's shaken hands with whom. I mean, you can do it with 4 or 5 or 6, but after that, you need a good system, otherwise you lose track of what's happened. Okay.
Can you just pause there for a moment, Tony? You have used the word system or being systematic. Being systematic, that's...
Shall we talk about being systematic?
Let's just take a pause, because you mentioned those words. Why is it so important to be systematic? Well,
a system is an organized way of doing something that's very clear, and you know exactly what you've already done, and you know exactly what you've still got to do to complete the task. That's a system.
So it's important to make a note of what you're doing as well, so you can follow. So it be organized as well.
Well, that's what is necessary for being systematic, yes.
Okay.
And you can plan in advance to work systematically, and indeed in many practical applications in life, if you don't work systematically, you won't succeed in what you're trying to do. And in the maths classroom, it's a good place for really developing that skill to make us a plan that's going to work, that will make sure that you don't leave out any possibilities, any possible solutions.
Now, wait a minute. You've just said that if I understood this correctly, that if you are systematic in the maths classroom, which will help you succeed in maths, that what I'm interpreting, that's a life skill. If you can do it in the maths classroom, you're developing the skills you need in life to be systematic about decisions you make, about problem solving, about generally living life and being systematic in the way that
successful, Caroline.
Being successful. There you go. Being successful in life. So how can you improve your chances at success in life? Do mathematics. So why do maths? That eternal question, why do I have to do this? I'm never going to do this again. Because it's training you in life skills, such as being systematic.
Yes, well, here we come back to the key questions, because the old-fashioned way of teaching was for a teacher to explain something to the children, expect them to understand, and then often it was explaining the method by which they were going to have to solve the problem. So the teacher would explain the method and then give them some practice exercises to see that they could follow the teacher's instructions. But that's being a robot. That is actually following somebody else's instructions. And now times have changed and computers do that brilliantly, much better than people ever could. So if it's a matter of just simply following the teacher's instructions and a method which is clearly set out, like a recipe for cooking, then forget it. That's a useless skill. That way of teaching doesn't work anymore. They may help children to pass tests, but it won't help them in life. And what they need is to develop skills and life skills that are really going to make a difference. They're going to be able to use computers as a tool or calculators, and they're going to be able to solve problems by thinking logically, thinking mathematically, reasoning. Now, I don't just mean problems in mathematics now, I mean all sorts of different problems. So let's come back to these key questions. So if you're not going to explain to the children how to solve the problem, but you're actually going to encourage them to find out for themselves, then a good teacher asks questions, and we call them key questions. So the first one here is all about being systematic, really. It's how can you be sure everyone has shaken hands with everyone else once and only once? So the teacher might tell the children that that's what they've got to do, Or she may ask them a question like that. They've started, they've gone round trying to shake everybody's hand, or trying to count how many, and then, or maybe they've got only a small group and they have think they've done this, they found the answer. She'll say, how can you be sure everyone has shaken hands with everyone else once and only once? Because another skill is being able to communicate ideas. And when a teacher asks a question, they want the children to be able to explain clearly the reasons for their answer. And so in life, when they need to communicate with other people, they can explain things clearly. So that's why asking questions helps children such a lot. You don't expect a number or some quick answer. You want them to explain why that's the answer.
So we've got being systematic, which also helps us communicate. So we've got communication and success through communication and being systematic, which one does derive from the other. And this is all through doing maths. I like this. I'm liking this a lot.
Now, what we said earlier was that if you're going to solve any sort of problem that seems quite difficult to you, then it's a good idea to start with small numbers or simple cases. And if you can solve it for the simple case, then you've got a useful way of thinking that might work for the big case, the big hard problem. So the next key question is, how many handshakes would there be for 3 people? That's quite easy. And then how many handshakes for 4 people? And that's quite easy. So you're beginning to get some better understanding of the pattern involved. And
so
then,
the pattern has been revealed by starting with a really, really simple example and then making it ever so slightly more complex each time, and therefore that's helping you understand it. And what these questions are doing is enabling the person that's facilitating, you're giving them literally the questions to help that learner figure it out for themselves.
yes, and then it's we're using this handshakes as an example, but these are general principles that apply to many, many problems that they might have to do in maths or they might have to do in life. Now, the next question is, can you use the same reasoning to find the answer for the whole class? So in a general sort of way, if you started with simple cases and you thought, oh, I can do this for small numbers, then the question to ask is, can you use the same reasoning to find the answer for the whole class in this case, or for the bigger number or the bigger problem in a general question?
So you're actually taking a leap. You're actually taking you're going from, okay, I'm getting the picture now, and then leaping to, whoa, so what would work for every case?
Yes. So this is a general principle. This is not just about handshakes. It's in general about solving problems that seem like big problems and quite difficult. Start with a simple case and then see if that you can gain some insights which will help you solve the big problem. And then the next question we're asking here is about handshakes. It's, could you find the number of handshakes for the whole school without actually counting them? Now here you're asking that question when the children have reached a point where they can tell you how many for 20, because that was the original question, or they can tell you how many for the class that they're with, you know, the number of children actually in that room at that time. And now you're asking them, we're generalizing. We're actually saying, okay, well, we've done it for this, as we started off, for this class or 20 people. Now, could we do it for the whole school? And now what we're doing there, and again, it's a general principle, although we're actually using handshakes as an example. The general principle is, now we're going to generalize. Now we're going to see if we can find a general answer that works for any number at all. And then again, we come back to communication. The teacher says, all right, the learner might have told them how many for 20 people. But now the teacher says, can you explain how you found your answer? That's where we're coming back to giving the learners practicing communication. And the last question says, what's special about the numbers of handshakes in different sized classes? So it's there really asking, and it could be a rule or a formula. Now the rule could just give a description of how to do it in words. No formulas, no algebra, just words. Or it might be a formula. So ultimately you want a mathematical formula. So if there are n people, then you want a formula which starts with n and gives you an answer that is a formula with n's in it. And so that's
n being the number of people,
yes,
that are in the group shaking hands.
Yes, that's right. That's right. So if n is 1,000, you could do it for 1,000, or whatever.
And it can be a conversation. You don't have to start with n. You can say for this number of people, and then shorten it to n once they understand that n is the number of people. And then you go, oh, let's not write all that in. Let's just put the number n, and we know it means the number of people.
But Caroline, they talk about it in words, talking about the number of people.
Yes.
And then you wouldn't be pressing.
And we know it means the number of people.
But Caroline, they talk about it in words, talking about the number of people.
Yes.
And then you wouldn't be pressing primary school children to get the formula, but you might by the time they were 15.
Mm-hmm. I'm just making the bridge between what we're talking about and using a letter, because letters can literally switch people off.
But this is a different way of teaching algebra. Children are not afraid of algebra if they're taught in this sort of way, because it comes naturally. Yeah. It's actually a shorthand. It's a shorthand, and my goodness, with SMSs and all sorts of messaging, they're very used to shorthand, and they actually see algebra as just a shorthand.
Maybe they should learn algebra on their devices.
So you saw earlier on that they were starting to make a table or a list on the board of how many handshakes there would be for 1, 2, 3, 4, 5, 6 people. We had got up to 4 earlier on, or the children in Bagamoyo had got up to 4. And the problem is, if you know the number of people, how do you work out the number of handshakes? And you can ask a question for 20 or 40 or 100. And there's a sequence of numbers, a number pattern. And there's actually some geometrical shapes as well here. We're going to talk about them. And then the last thing we just talked about before the break, can you write a formula for using H for handshakes and N for the number of people? So the formula starts H equals, and then after that comes something that has N's in it, which tells you the number of handshakes. And it's a sort of shorthand for the answer. So you could make N equals 20, or you could make N equals 40, as we question here. You could make N equals 100, or whatever you choose.
And once you get to that stage, you don't have to think about it in terms of, you've already thought about it, you've already worked out what the connection is. So you just have to put in how many people, and you know how many handshakes.
Now, if we get the formula, we may well think, if we're mathematicians, or maybe we're 16, 17, 18, and we spotted something that we've seen before, not necessarily in relation to handshakes, we may know the answer, we may know the formula. And then you might have a way of doing it that's different from the counting method. We've used this today to explore the ideas of principle of a way of teaching by helping the children, encouraging the children, making it possible for the children to experience working things out for themselves. Now, what they worked out was these numbers of handshakes. So obviously, if you're one person on your own, then you can't do a handshake. Well, you could do it with yourself, but we're talking about shaking hands with somebody else, one-to-one greeting. But if there are two people, then there's one handshake. And if there's three people, children worked out that there were 3 handshakes. And if there were 4 people, there were 6 handshakes. And if there were 5 people, there were 10 handshakes. And for 6 people, there were 15. And for 7 people, there were 21. Now then, the question is, can you see a number pattern there? Is there a pattern in those numbers? 1, 3, 6, 10, 15, 21.
Yeah, it follows. You can predict what the next number is.
Can you, Caroline?
I can. I think
well,
so.
you can. You've seen this, Caroline.
No, yeah, I know. I'm not going to give the answer, but if you look, it's a bit like those problems where they show different shapes and you can predict what the next shape's going to be. If you use that same principle, you look to see what happens between each number. This is actually a very simple one. You can really.
But in an investigation like this, the children have ownership of it now. They're curious. Yeah. They're interested. You actually, you might not take very long if you're working with 14, 15-year-olds, because they're quite quick to spot patterns and to tell you why the pattern is like it is. So it's done quite quickly. But if you're doing it with 9, 10-year-olds, then this will take much longer, and they'll enjoy doing it because they're really finding out at their own pace. Now, if you do this with a class, it's almost certain that somebody will spot that number pattern. And, well, they will tell you. And other children you might want them to write it down and not say what they found, so that they give other people a little bit more time, or to work in groups and then have time to think it out, so that they're not just listening to somebody telling them and saying, oh, yes, of course. They're actually working it out for themselves. So what we've got here is a sequence. So the first number, I've shown you this sequence in a slightly different way with the red balls. So 1 and then 3. What we have underneath is we've got the numbers 1, 2, 3, 4, 5. So that's the numbers of people at the bottom. For 1, 2, 3, 4, 5 people, the numbers are the numbers that you can see there in the balls. And what sort of geometric pattern are you seeing?
What do you mean by geometry? What do you mean?
Well, geometry is shape, isn't it? What shape do you see? No, you see, I'm sure you see, nobody has to explain it to you. Even if you're 5 years old, I'm sure you see triangles.
Yep.
And these are called triangle numbers. And the reason they're called triangle numbers, 1, 3, 6, 10, and so on, are called triangle numbers, is because if you have objects, that number of objects, you can arrange them in a triangle. And there you have the triangles for one handshake. Okay. So if you've got 2 people, you have one handshake. And if you've got 3 people, you have If you've got 3 people, you have 3 handshakes. And if you have 4 people, you've got 6 handshakes. Yes, but in the sequence, where they occur in the sequence, the first number's 1, the second number's 3, the third number is 6, the fourth number is 10, and what's the next number? What's the 5th number in that sequence? Okay, and you can see it's the same sequences with the numbers of handshakes. And if you put one more layer of balls there, how many extra balls are you adding to make the next triangle? Each time, the top one, there's 1 ball, then there's 2 balls, then there's 3 balls, and you're going down, and the bottom one, in the one you see for the 4th one, is 4 balls, and the next one will have 5 balls on the bottom. So you've got 1 plus 2 plus 3 plus 4 plus 5, and 1 plus 2 plus 3 plus 4 plus 5 is 15. So what you have is a sequence of triangles, and we call them triangle numbers. And that's what the children in Bagamoyo discovered. They discovered this sequence of triangle numbers. And this is magic, because once they know that it's all about counting numbers and adding one more number. Each time you add the next number in the sequence. So you add 1, then you add 2, then you add 3, then you add 4, then you add 5. And this leads you to the answer. So we're going to leave that there, aren't we, Caroline? And we're going to come back to
I'm just going to say this one thing, and that is, once they realize for themselves about triangle numbers, that might be extremely useful many times in their school career, and if they just doing maths in general, once you've recognized that pattern, you can use it again and again. It can be extremely useful.
Well, it's really strange. It comes up so many times. So what we've got is 1 plus 2, 1 plus 2 plus 3, 1 plus 2 plus 3 plus 4, 1 plus 2 plus 3 plus 4 plus 5, and so it goes on. We're adding the counting numbers. And that sequence comes up. Oh, it seems to come up everywhere. You seem to trip over triangle numbers all over the place in mathematics. So you might want to explore this further by looking at the Handshakes or Bows learning pack on the Aiming High website, or come back next week, where we'll do something that appears really very different, but it links with this, and it's a quicker way, a different way to get the answer for any number of people.
And before we finish, because we're just about to finish, if you would like to support Aimsec and support this work that we're doing with globally and across Africa and globally, that you can go to GoFundMe and search for Benefiting Children by Empowering Teachers. The link is in the description. So if you'd like to do that, and go all links, you've got our YouTube channel where we've got videos to help you with these. You've got the links to the Aiming High website, got the links to the Aimsec, the daily starters, all of that. And that we've got a group as well, which you can join and be part of the community. And it's all the links are all in the description. This activity is called Handshakes. There are many more engaging and exciting activities with documents and resources for schools and home learning that are free to download from the Aiming High website and app. Follow the links in the description. Please also support Aimsec through the GoFundMe link given. Subscribe, comment and ding the notification bell to make sure you don't miss our latest videos.